yeah, so basically whenever we say that we have a graph, we usually represent something like this, okay? And this is basically an x-axis and y-axis. So this is the x1, this is the y1, okay? And what this means is that this equation in the middle, this line, y, the dotted line, y equals to x, it is special because it tells us about a relation between x-axis, the function, and its inverse, okay? So that is why this is an important equation to have. What it does is that it tells us if there's a function like this. So let's suppose there's a function. So let's suppose this is a function. So y is equal to x line. If you reflect this line in that, so let's suppose you reflect it like this. ठीक है, ये कुछ ऐसे करके बन जाएगी. Yeah. So if you reflect it in this, so this line is basically the inverse. So let's suppose this was your f of x. Then this line would be f inverse of x because this is reflection. Okay, same for f of x. F of x and f inverse are reflections of each other in y is equal to x line, which is why this is important. But it doesn't always have to be. You can have all sorts of equations, all sorts of graphs, and they can all be two depictions, two forms of the same pattern, same behavior. For example, if I say that this is y equals to x plus 2, then all it's telling me is that there is a value of x and y is always 2 more than that. So if x is 0, y is going to be 2. If x is 1, y is going to be 3. Okay, so that's a pattern that we see. Now this pattern can be written as this form, which is basically algebraic form, or this can be written as this form, which is basically a graph. So graph and equation are basically two sides of the same coin. The way to look at this, let's suppose I had an equation and that was x cubed minus 3x squared plus 5, and that is y. So let me plot it for you. All right, so let's plot it. Yeah, so my function of y equals x cubed minus 3x squared then plus 5. So plus 5. Okay, and we talked about earlier on, yaad hoga aapko, that we talked about that this is a root of this function, and this root in this case is a real root. But this function must have 3 roots because it is x power 3. But both of the other roots are imaginary because it is not touching the x-axis at any other point, right? So here's the thing. When I say that this point is 5, 0, 5, right? So what am I actually trying to say about the curve? Now there are two ways to look at it. One is that I can be like that, all right, let me take a picture of this. Yeah, so one is that I can be like, okay, I have this equation, y equals to all of this. Let me copy that as well. All right, so I can say that y is equal to all of this. Now here's the thing. At x equals to 0, y is 5, right? Clear? So I mean, I need you to pay attention to this. Now there are two ways that I can deal with this. One is that I can be like, oh, all right, when x is 0, y is 5. So if I say that y is actually f of x, then that would mean that when f of 0, that would mean 0 cubed minus 3 times 0 squared plus 5, right? Which basically means 5. So that's one way of saying what the value is. I can say that when x is 0, y is 5. And for that, I can use the equation and I can put f of 0 in there. So x becomes 0. Wherever x goes, it becomes 0. And I get 5 as the answer, right? Clear? Now, there is another way to look at this. What if I wanted to divide this equation? And if I wanted to divide this equation by x equals to 0. Now, that is one way of doing that. That I can say that, okay, when f is 0, when x is 0, y is 5. Another way to look at this would be that I divide x cubed minus 3x squared plus 5 with x. Now, obviously, that would mean that I multiply x squared here, and that way I'm able to get x cubed. All right, this becomes 0. I get minus 3x squared. I multiply this with minus 3x. I get minus 3x squared, becomes 0. Now, there is absolutely no multiple of x that will give me 5 here. मैं x को किसी से भी मल्टीप्लाई करके 5 नहीं बना सकता, right? So that means that this is actually a remainder. When this is what I'm dividing, this we call dividend, and this we call divisor, and this is obviously our quotient. Now let me back up a little bit. Let's try to simplify this. Let's say I want to divide 5 with 2. So what is 5 here? What is the name of this 5 here? Dividend. Very good. And what is 2? So how will I do this? 2 times 2 is 4. So 1 is the remainder here, right? So basically, if I wanted to get 5 back, I can do it like this. So I can write this equation as 2 whole 1 over 2, which will simply become that multiply. If I want to get 5 back, I multiply, I'll get 5 back, right?
Yes.
Let's do the same thing here. Let's do the same thing here. Let me try to write it like this. So this is going to be x squared minus 3x whole 5 over x. I multiply this with this and I add this and I will get the equation again. Let me try this. Basically, I'm saying that I multiply this with this and I add this to get my function back. So does that really happen? Of course it happens. This is simple math. We learned it in grade 5. But how is this division related to the graphs? It's really simple. When you are dividing whatever equation you have, when you're dividing by x, the remainder you get is actually the value of y that you have. Let me try once more.
Yes, sir.
Okay, so the value when x is 2 is 1. Okay, so the value when x is 2 is 1. Let me try it again. All right, but this time I'm going to do synthetic division because that is simpler. So when x is 2, y is 1. That's one way, which I can simplify as when fx is 2, this becomes 2 cubed minus 3 times 2 squared plus 5, and this gives me 1 as the answer, right? Now let me try it, but using synthetic division. So 1 minus 3, 0, 5. Why 0? Because x has a coefficient 0 here. There's no x term here. So I'm putting x equals to 2 here. So I'll just let this come here. 2 times 1 is 2. Become minus 1. 2 times minus 1 is minus 2. I let it come here. This becomes what? Minus 2. 2 times minus 2 minus 2. That is 4. And that is minus 4. So 5 minus 4 is 1. And there you go. This is my remainder when I divide it. So using synthetic division. So what am I actually saying? I'm saying when x is 2, that means x minus 2 equals to 0, right? The answer, this is what I'm dividing it with. So x minus 2 times these numbers here, 1x squared minus 1x minus 2. And when I add the remainder, I should get my equation back. Let's try it. X cubed minus x squared minus 2x squared plus 2x plus 4 plus 1. And there you go. This minus 2x, this minus 2x. X cubed minus 3x squared plus 5, right? Amazing, right?
Yes.
I'm able to get whatever value I wanted just by looking at this thing and division. So that brings me to remainder factor theorem. Remainder factor theorem says that whatever value of x you have, if you divide the equation by that, then the value of y you get is the same as if you were to put the value here. मतलब मैं x minus 2 से डिवाइड कर रहा था तो उसका मुझे रिमाइंडर उतना ही मिला है जितना x में मैं 2 पुट कर दूं तो मिलेगा, या अगर मैं ग्राफ में से बनाऊं तो मैं ग्राफ से उसे रीड कर लूं तो मुझे मिलेगा. So simple. So tell me, if I were to look at this graph and if I were to divide it with x equals to, let's say, 1. So I'm going to divide this with x equals to 1. So what value should I get? This one, 3. So that means if I divide the equation by x equals to 1, I get 3 as my remainder. In other words, I'm getting the remainder is always f of whatever your value is. Interesting, right? That you are able to get the remainder based on whatever that value is. Now, here's one more thing. What if I were to divide it with this point? This x equals to minus 1.104. Let me try it. If x equals to minus 1.104, that thing becomes this that I'm dividing it with. And I know that f of x is 0 because I can read it from this point. Now, how come this is a root? It's a root because the remainder, as I've already told you, remainder is f of x. So the remainder, when f of minus 1.104 is put in, that is 0. That's the remainder. So that means this thing is a factor. Why? Because we learned factorization. We learned factorizing cubic terms. We learned how to factorize square terms. We learned how to factorize quadratic equations. And all of this was actually coming from factors. It's literally in the name, factorization. All the roots are basically coming from the factors of the equation. So that means if you really want to figure out what an equation is, you simply take its factors and you multiply them, and you don't have to add a remainder. Because अब देखो, यहाँ पे 2 times 2 plus 1 करना पड़ रहा था ना. But if I have to divide 4, then I don't have to add a remainder. I'll just do 2 times 2 plus 0 and I'm able to get 4 because 2 is a factor of 4. No remainder here. That means when you have factors, you just multiply them. You don't have to add a remainder. That means your f of x is basically nothing but factor 1 times factor 2 times factor 3 times how many factors you have plus 0 because there is no remainder. So that is remainder and factor theorem. It simply says कि आपने equation देखनी है. There are 3 ways to look at it. One is you make it a function, you make it an algebraic function, and if you want to figure out what the roots are, you factorize it. Another way to look at it, you make the graph, and wherever it cuts the x-axis, let that be your factor because the remainder is 0 over there. And if the remainder is 0, the thing is your factor, multiply all the factors and you will get your f of x back. Third one, if you want to figure out whether something is a factor or not, simply put that value in there and see if it's a root. And what's a root? Root is when your x-intercept is there. Root is when your y value is 0. And why should y value be 0? It should be because it's a remainder. So this is all related to what we were doing before. Your y value for the graph, regardless of where you take it, any point you pick, that y value is the remainder if you were to divide the equation by that x value. Any x value, you can divide the equation with that, get your equation back. So amazing. We are able to see what the graph is or what the equation is. All of that just by looking at these factors. And factors are easy to figure out if you know what x value is. Put that in there, see if your y becomes 0. If y becomes 0, it's a factor. If y doesn't become 0, it's not a factor. And it's as simple as that. All right. Now, what do we do with this graph then? Basically, graphs help us. Graphs help visualize relation between things. We have talked in detail about quadratic graphs. We have talked in detail about cubic graphs. But we haven't talked about the most simplest of relations, which is linear relation. Okay, so linear relation is easy to simplify. We say that linear relation always depends on 2 things. How does something change? And what is the starting value? This is your starting value, like where does it have to begin? And this is the rate at which it changes. So mx plus c, 2 things tell us how a linear relation develops. So let me give you an example. Let's suppose I say that temperature right now is 14 degrees Celsius. So this is my temperature right now. I'm going to call it T0. This is 14 degrees Celsius. And I say that, in fact, I should call it capital T so that this is temperature. Okay. And I say that as after every 1 hour, temperature drops by -1 here. Okay, so it drops by -1 degrees per hour. All right, so let's see. This is my starting value, right? And this is what? This is my rate. I'm going to give many different names to this rate. I'm going to call it gradient. I can also call it tangent or tan. Okay? If I'm into trigonometry. Or I can simply call it M. But all M is telling me is it's falling -1 per hour. Okay, so let's see how we can graph this relation. So let me make a graph paper here. All right, so we have one. And let me put the x-axis and y-axis there. Okay, so I was saying that right now, when time is 0, temperature is 14, right? And it's falling -1 every hour. So after 1 hour, it will fall 1. So I'll simply be like, okay, after 1 hour, which means when time is 1, it has fallen by 1 degree Celsius, which means that the temperature is 1 down. So basically 1 step down. So after 1 hour, it's going to fall. So 1 hour बाद ये होगा and it's going to fall by 1. After another 1 hour, it's going to go here and fall by 1. तो अगर मैं सिर्फ इसको यहाँ पे देख लेता हूँ तो basically मुझे so tell me, looking at this relation, when will the temperature be 0?
I can see it now.
Hold on.
Yes, I can see it.
You can see it now? Yeah.
Yes.
So you can see that after 1 hour, it has dropped down by 1. And that is enough to give us the line of the curve. Basically, this is telling me the linear relation between them. So how do you draw a line? You simply start with your starting value, which is called y-intercept. And you use your gradient to figure out the next point. And you have 2 points there right away. You don't need to make the table. You don't need to go through any trouble. You just have to look at that. And then you can simplify or generalize this relation. You can be like, okay, y is going to be my rate times x plus the starting value. And that is true for any linear relationship. So this is going to be y equals to -1x because that's the rate at which it's falling, plus 14 because that's your starting value. All right. So how do we actually figure out the rate? Rate's easy. It's m. And it's always the change in y compared to change in x. Whenever I use the symbol delta, it means change. Okay. And we're going to talk in detail about what change is और ये कहाँ से आता है और कैसे आता है. ठीक है? So change in y compared to change in x. Now here's the thing. If there are parallel things or parallel relations or parallel lines, तो उनका मतलब है कि उनका starting point same नहीं हो सकता, लेकिन rate तो same हो सकता है. That's why they're parallel. So that would mean that the changes are same in both of them. एक parallel relation है ना, उसकी change दूसरे parallel relation के बिल्कुल same होती है. Starting value different हो सकती है. So that means your gradients for two parallel relations are going to be the same. But the relations that are related by perpendicular 90-degree angles, उनकी changes जो होती है ना, वो opposite होती हैं. एक की change जितनी change y में आती है, उतनी दूसरे के x में आती है. उसका basically होता ही है कि अगर एक का relation है ना m1 is equal to change in y over change in x, तो दूसरे का होता है change in x divided by change in y in opposite direction. That's how they relate, which simply means that if I were to multiply them, I will end up with simply this. The relation of rate between perpendicular lines is m1 if that's the first one's gradient, तो वो दूसरे का negative reciprocal होगा. It will be reciprocal in the opposite direction. In other words, you can say that this is m1, m2 equals -1. So that's one relation. This is one relation. This is for parallel. This is for perpendicular. Okay, but what exactly is the gradient? It's simply change in y and change in x. And how do you figure out change? You pick any 2 points, y2, y1, and x2, x1, and you subtract them. That's how you find change. no matter what the points are. How do you find starting value? The starting value is when x is 0. That's your starting value, right? The remainder you get when you put x equal to 0. That's your starting value. So there are multiple ways of achieving it. One is you start with, okay, my y is rate times x plus starting value, which I'm going to call y equal to mx plus c. You're going to be like, okay, if I know y, if I know m, if I know x, then I can simply find c, right? Because c is nothing but 0 and c, right? And any point x1, y1 can be used. So you can be like, okay, m equals y1 minus c over x1 minus 0, which simply gives you what? y1 equals mx1 plus c. There you go. So you can simply convert y equal to mx plus c to y1 equal to mx plus c if you put in the values, and that way you're able to get your c. That's one way. You take the value, you first find the gradient, then you put that in there in the equation to find the c, and then you're able to figure that out. The other option is actually really simple. You're like, okay, hold on. I don't really know what that any point is. Like, if you want to figure out any point. ठीक है, ये तो c के लिए था ना, but if I want to figure out any point on the line, so I'll be like, okay, that point is x, y. I don't really know what that point is. It's just वहां पे x की वैल्यू x है, y की वैल्यू y है, कुछ भी हो सकती है, मुझे नहीं पता. लेकिन मुझे क्या पता है? मुझे एक और पॉइंट पता है x1 y1 और मुझे एक और पॉइंट पता है x2 y2 और मुझे इन तीनों को यूज करके इक्वेशन निकालनी है. तो इसको जरा गौर करो. बेसिकली मैं क्या कह रहा हूं? मैं कह रहा हूं ये एक ग्राफ है, इस पे देयर इज अ पॉइंट हियर जो है x1 y1. I'm going to call it A. So this is point A. This is a point B, which I'm going to call x2 y2. And there's an unknown point U, which can be anywhere on that graph. Okay, and I know for sure that that point is actually on this line. Okay, so any point U on this. Now, what can you tell me about the gradient of AB and the gradient of AU? It's the same straight line, or they're parallel. So what do you think is the gradient of AU and gradient of AB?
So they're both the same.
They're both the same. Perfect. So gradient of AU and gradient of AB is the same, right? So that means if I want to find gradient of AB, I'll be like, okay, y2 minus y1 for AB is equal to x2 minus x1, right? And the gradient of AU will be y minus y1 over x minus x1, right? Now, what is this whole thing? This is m, right? तो मैं कह सकता हूँ कि m equals y minus y1 over x minus x1. In other words, y minus y1 इस साइड पे रह जाएगा, इस साइड पे बन जाएगा m into x minus x1.
Yes, sir.
And that is a way to find equation of line. Y minus y1 equal to m x minus x1. And you can find the equation of line. You don't even have to know the starting point. कोई भी point हो, क्या फर्क पड़ता है? Take that xy. And that's the thing. If you have to find any unknown point, take it xy. And know that if it's a straight line, तो उसका gradient कहीं और दो points के बराबर होगा. और अगर वो perpendicular है तो कहीं के भी वो 90 degrees पे होगा, तो m1 m2 minus 1. अच्छा, फिर अगर मुझे एवरेज निकालनी हो, एवरेज पॉइंट, तो एवरेज पॉइंट बड़ा आसान होता है, उसको हम कहते हैं मिड पॉइंट. मिड पॉइंट क्या होता है? एवरेज. तो एवरेज कैसे निकालते हैं? दो चीजों की एवरेज कैसे होती है? आपके एक एग्जाम में आते हैं 88, दूसरे एग्जाम में आते हैं 96. दोनों की एवरेज क्या होगी? 88 प्लस 96 डिवाइड बाय 2, राइट? यही एवरेज होती है ना.
Yes.
आप कहते हैं कि नहीं, अब मैंने तीसरा एग्जाम भी दे दिया, तो तीसरे एग्जाम के अंदर आप क्या करोगी? आप तीसरे के भी स्कोर, लेट्स सपोज यू गेट 98 नाउ, so you divide them all by 3, right? You won't divide by 2 this time. And that is the same thing with average. If you want to figure out midpoint of 2 points, 2 points की average निकालनी, तो आप एक का x, दूसरे का x ऐड करोगे डिवाइड बाय 2 कर दोगे क्योंकि 2 पॉइंट्स हैं, फिर आप एक का y दूसरे का y डिवाइड ऐड करके डिवाइड बाय 2 कर दोगे, आपको मिड पॉइंट मिल जाएगा. दिस इज योर एवरेज पॉइंट. बट यू आर लाइक नो नो नो, आई डोंट वांट दैट. बेसिकली मेरे पास तो एक रेक्टेंगल है, ठीक है, और मेरी तो रेक्टेंगल ऐसे करके है और मुझे रेक्टेंगल का मिड पॉइंट चाहिए. तो मैं कहूंगा कोई मसला नहीं है, आपके पास 4 पॉइंट है ए बी सी डी, चारों को x को ऐड करो, 4 से डिवाइड कर दो, चारों के y को ऐड करो, 4 से डिवाइड कर दो, एंड दैट वे यू आर एबल टू गेट योर डायगोनल, ये पॉइंट सेंटर वाला, बिकॉज इट्स एवरेज ऑफ ऑल द पॉइंट्स ऑन द रेक्टेंगल, राइट? एंड दैट
Yes.
goes for squares, that goes for any regular shape. There you go. Now this is interesting because इसके बारे में तो मुझे और भी बातें पता है. मुझे तो ये भी पता है कि यहां से अगर मैं एक लाइन लगाता हूं B से D के साथ, तो वो लाइन इसमें से गुजरेगी, और अगर मैं वही एक और लाइन A से C को लगाऊं तो वो भी इसमें से, सॉरी, अगर मैं एक और लाइन लगाता हूं तो वो भी इसी में से गुजरेगी. And that tells me if this is actually the point where they both meet. और मुझे पता है कि line is nothing but y is equal to mx plus c, और ये भी line कुछ नहीं है, y is equal to mx plus c है, और मैं इनको simultaneously solve करूं तब भी ये point of intersection मिलता है, मैं ग्राफ में solve करूं तब भी ये point of intersection मिलता है. Interesting. So graph and equations are actually two ways of looking at the same pattern. तो जहां पर वो मीट कर रहे हैं वो मुझे पॉइंट मिल जाएगा. तो अगर मुझे एक की लेंथ पता है मैं दूसरे की लेंथ निकाल सकता हूँ. होल्ड ऑन, हाउ डू यू फाइंड लेंथ्स? लेट्स सी. एनी लाइन दैट यू कैन थिंक ऑफ इज एक्चुअली अ डायगोनल ऑफ अ पाइथागोरस ट्रायंगल. कैसे भला? राइट एंगल ट्रायंगल है ये, तो ये देखो, ये देखो. तो इसका मतलब है मुझे अगर इसकी लेंथ निकालनी है तो ऑल आई हैव टू डू इज, वेट अ मिनट, दिस इज x1 y1, दिस इज x2 y2. मुझे इसकी लेंथ देखनी है ना. पाइथागोरस थ्योरम क्या कहते हैं? दिस लेंथ इज इक्वल टू दिस स्क्वायर्ड प्लस दिस स्क्वायर्ड. तो दिस इज माय चेंज इन y, दिस इज माय चेंज इन x. Rise over run, right? So I can simply say that distance, if this is a and this is b, distance from a to b squared is equal to change in x squared plus change in y squared. और चेंज इन x क्या होता है? अभी पहले भी किया है, x2 minus x1. और चेंज इन y क्या होता है? y2 minus y1. तो ए बी का डिस्टेंस मिल जाएगा, स्क्वायर को खत्म करने के लिए स्क्वायर रूट ले लो, इस साइड पे खत्म हो जाएगा, एंड देयर यू गो, डिस्टेंस मिल गया. कुछ भी नहीं है पाइथागोरस थ्योरम में. तो आपके पास कोई भी जो इक्वेशन है वो इसी तरह से आराम से शो हो सकती है. और ये लीनियर रिलेशनशिप का फायदा ही होता है कि दे आर वेरी इजी टू अंडरस्टैंड, वेरी इजी टू ड्रॉ, वेरी इजी टू सिंप्लीफाई एंड समराइज. उनके पैटर्न्स हम बड़े आराम से निकाल सकते हैं. In the next lesson, we are going to talk about how we can make almost all relations linear, which is amazing. क्योंकि ये simplest relation है, हम तकरीबन बहुत सारे majority reducible relations को linear बना सकते हैं. And that's simple. And we'll talk about that in the next lesson. All right? Take care.